Alright, today we're going to move on from graphing and we're going to learn how to solve with a different method, which is called factoring. We'll review how we did graphing and then how it translates into the factoring method. So it says solve the equation below by graphing. So here's my equation, x squared minus 4x plus 3 equals 0. Remember, on my calculator, I hit y equals, clear out whatever's in there. The left-hand side of your equation is y1. And the right-hand side of your equation is y2. And then you just press graph. If it's hard to see your screen, you can fix that by pressing zoom and then going down to zoom standard. Zoom standard just makes the window the 10 by 10. So now I can see a better picture of my graph. So the first thing that probably jumps out at you is you don't see that other horizontal line that we're used to seeing cross the parabola or the U-shape. The reason is the horizontal line in this case happens to be the x-axis. And why is it the x-axis? Because that's where y equals 0. So if you typed in y equals 0, this would be the line you would get. But we can't see it on the calculator because the calculator is just tracing over the x-axis. So the intersection, this time, we're just looking where does the graph cross the x-axis. So there's two spots where I see it crossing the x-axis. We do our second trace intersect. And I move my cursor. The first spot is close to right there, and just press enter, enter, enter. So one of my intersections is at 1. I have to repeat the process though and hit second trace intersect and go to the right for the other intersection. So I'm going to move my cursor over to the right, press enter, enter, enter. So the solutions to this equation are x equals 1 and x equals 3. What do we call the values that cross the x-axis? Well, we've used a couple different words. These are called the x-intercepts. We've also called them zeros. And today we're going to use a new word called roots. So any of these words mean the same thing. The x-intercepts are where they cross the x-axis. That is what the zeros are, and that is also what the roots are. There's another way to solve this equation. It's called factoring. So let's look at the example we already graphed. Here's the same equation, just not equal to 0 in this case. What were the roots of this equation? Well, the roots of this equation we already said are x equals 1 and x equals 3. You could use graphing to find the roots, but another method that you might be interested in using is called factoring. Factoring we kind of already started with the products and sums puzzles. And how it works for a quadratic equation is you look at your last term, so in this case it's the 3, and you ask yourself what two numbers multiply together to give you 3 and add together to give you -4. So in terms of our sums and products puzzles, we want to figure out what numbers are multiplied to get together to get the top number and added together to get the bottom number. And in this case it's just coming from here in the equation. So looking at your factor chart, for 3, the only two numbers that multiply together to equal 3 are 1 times 3. But remember, our factor chart doesn't include negatives. So also to get +3, I can use -1 and -3, because those multiply together to give +3. Which two factors added together will give me a -4? Well, the two answers have to be negative in order for you to get -4. So my factors of 3 that multiply together to equal 3 and add together to equal -4 are -1 and 3. So we can factor this equation into two sets of parentheses that multiply together to equal this guy. And there's a couple ways to do this. We use what's called the box method. In the box method, you take the first term and you write it in the first box. So x squared just goes into the first box. You take the last term and you write it into the corner box. And then you use the outside, kind of like a rectangle, to figure out what pieces multiply together to give you the inside. So here you ask yourself, what two numbers multiply together give you x squared? So this one's an easy one. This is just x times x. Then you look at the 3 and you ask yourself, what two numbers multiply together to give you 3 and add together to be the -4? So there's a condition on it. And we just did the work over here. The two numbers that multiply together to give you 3 and add together to give you -4 are -1 and -3. And then using the multiplication, where you multiply the row and the column, I'm going to take x and multiply it by -1. So this becomes -1x. Here I'm going to take -3 and multiply it by x and get -3x. It does not matter if the -3 was here and the -1 was here. In multiplication, it has a property that's called commutative, which means you can multiply in any order and you'll still get the same answer. So I'm going to write down my values inside my box in the middle. That's x squared minus 1x minus 3x plus 3. I notice there are like terms right here, so I'm going to combine them. So I'm just showing you where the original equation comes from. This is where we started, and now I'm getting to here. The two factors that we can multiply together to get to this guy come out of our little box, and they're the numbers on the top and the numbers on the side. And I'm going to write them inside of parentheses. So the factored form of this equation is these two numbers multiplied together. So it becomes x times x, which is x squared, x times -3, which is -3x, -1 times x, and then -1 times -3. So if you take a look, what do you notice about the terms in the factored form and the roots? So if you go back to our original question, the roots from when we did the graphing, what do you notice about the roots and the terms? Well, the terms in the factored form are just the opposite sign of the roots. So they are the opposite value or opposite sign. I'm going to put they have the opposite sign. So we're going to practice factoring. Factoring is when you're trying to find two numbers that multiply together to give you this quadratic. So we're going to use this process. So turn to the next page and let's look at number 1. And I'll work through number 1 with you, and then you can try the rest on your own. Alright, so we're going to follow the same procedures. It says factor each quadratic into factored form. So here's my quadratic expression, or my equation. It's a function. Remember, the first term, x squared, always goes in the first box, and the last term, 8, goes in the last box. So now I'm looking for the numbers that multiply together to give you the number in the box. So what two numbers here would give me x squared? This one's easy to find out. It's x times x. Here I'm looking for two numbers that multiply together to give me 8, but they have to add to equal the negative term of -6. So if I look at my factors of 8, my factors of 8 are 1 times 8 and 2 times 4. This list does not include the negatives, so I also have to include negatives. I have -1 times -8 and -2 times -4. I'm looking for the pair of factors that multiply to give me +8 but add together to be -6. So I can automatically cross out the positives because they're not going to give me a negative answer. Here I'm looking for which combination will get me to -6. -1 and -8 is -9, so it can't be that. So it's got to be -2 and -4. Again, it does not matter which order you write the -2 and the 4, as long as you get them, that's all that matters. So multiplying across and down, I get -2x here and -4x here. And then you can check, if you get this original problem, you did this correct. X squared, combine these two, is -4x minus 2x, which is -6x, plus 8. So the factored form of this equation is x minus 2 and x minus 4. The solutions, or the roots, are just the opposite of what's inside the parentheses. When you set this equal to 0, x would equal 2, or x would equal 4. Again, if you are uncomfortable with this, you could have graphed it and found the solution as well. If I just set y2 equal to 0 and do x squared minus 6x plus 8 and graph it, I can look and see where it's crossing the x-axis, and I can get the exact answer by doing second trace intersect and pressing enter, enter, enter. There's my first root, and then the other one, there's my second root. Okay, so try problems 2 through 5, and then try to do the summary and see how you can do with these. This is a new concept, so I know it's going to be a little bit more challenging, but good luck.